In this short tutorial, I'm going to introduce you to one-way ANOVAs in Jamovi. Jamovi also has the option for a factorial ANOVA that is covered in a different video by Data Lab CC, and the link should appear above in a minute. ANOVA, or analysis variance, is very similar to a t-test in that it allows you to compare the means of different groups. T-tests allow you to do that for one continuous variable split by a binary variable, i.e. gender, male, female. ANOVA allows you to compare the means of one continuous variable and multiple conditions, or two or more conditions. So let's say you have income in categories or levels of education. So I'm going to talk you through that now. Again, very simple. Obviously, you go to ANOVA, one-way ANOVA, brings up the screen where you will select your dependent variable and your grouping variable. I'm going to select socioeconomic status and a variable that records an extremism score as a dependent variable. ANOVAs make a lot of assumptions. One of the assumptions is that your data is normally distributed. In this particular case, I know that my variable is not normally distributed, but we'll pretend that it is just for the purpose of this tutorial. But you would check that by clicking on the normality test. If the Shapiro test comes back with below 0.05, then there is a difference to the normal distribution. So you would have to run a Kruskal-Wallis test instead of an ANOVA. The other thing that we want to check is the homogeneity, or equality of variance between the different factors. And we will run a test here. In this particular case, again, we see that there is a difference between variance. This impacts which variance test we pick here. If the equality is not equal, then we'll pick the Welch's test. If it is assumed to be equal, then we'll pick the Fisher's test. So in this particular case, we'll pick the Welch's test. So up here, you already have the one-way ANOVA outcome. Let's get a descriptive table and let's get some plots. So you get a table that basically tells you the extreme sum score and the mean of each of these, and the standard deviation of the mean within each of these scores. And here you get a plot that shows you the means plotted as well, and the confidence intervals. Sorry for the not neat labelling. Hopefully that's something Jamovi will sort out in the future. What we'll also want, given that our result is significant and that there is a significant difference in means between some of these groups, we're going to run a post-hoc test. Again, that will depend which test you've done, the Welch or the Fisher's exact tests. If you've done the Welch's test, you'll pick the Games-Howell unequals variance test, post-hoc test. If not, you'll pick the two-key test. And we will also report the test results, the flag significant comparison. And what we get here is a big table. Let me make that bigger so you can see it. Obviously, there's nothing here because this is the mirror image of this top, but here you'll see significant results. So, for example, there's a significant difference in mean between part-time employees and those in higher education, and it's of negative 0.544, and here again we see the significant result. So that's how you run a one-way ANOVA in Jamovi.